Okay, now we go to the sample problem 10.2. And if you do not have the PDF, or if you don't have the PDF, I have got the hard copy at the entrance. Now, and now the problem is like this. The problem is that we have two bars. We have two bars and a spring. We have two bars and a spring. So we need to determine something. Determine the expression for theta. Expression in mathematics is this one, and for the tension in the spring. So determine these two things. We determine these two things. Okay. Now, and of course, the question does not give any numbers. There are no numbers. But we have H and we have K, and H is the unstretched length of spring is H. That means unstretched is this one, and the constant of the spring is K. Constant of the spring here means that F equals to KH is K. It's okay. So we need to determine theta and F tension. And then what do we know are H and K and this theta and L. We know L, we don't know theta. And we know P. First of all, we draw the free body diagram of the whole structure, and for the free body, we draw it like this. We draw the free body diagram, and the free body is this one. We do not the spring is outside the free body. It's okay. The spring is outside the free body because we need to determine the tension. Because we need to determine tension, so we put it outside the free body. So the free body diagram looks like this. It's okay. The spring is in another free body. It is not in this free body. So we have these forces. You can check it. You can check. And because this one is a roller support, we have only Cx, we don't have Cy. And we have P, and we have, because A is a pin support, we have Ax and Ay. And for the spring, because for the spring has, suppose the tension of the spring is Fs, we have this one. And by action and reaction, we have these two. It's okay. Now we have 6 forces. 1, 2, 3, 4, 5, 6. We have 6 forces here. But as we said, some of them, because we have 0 displacement. If this one equal to 0, this one equal to 0. So for these four, we don't have virtual work because we don't have displacement. Because point A is fixed, so these 3 we do not consider these 3. And point C we cannot move point C in the x direction, so this one is also equal to 0. So we only have 2 components in the virtual work principle. We only have this one. It's okay. The remaining thing is how to write P and how to write YB and YC. And here again, don't use my way of writing things, but not the book's one. And we write YB, and it's okay. This one is from virtual work principle. Virtual work principle gives us this one. and P is equal to minus P negative Pj because it is going down. It's going down. Now, if we determine angle theta is in this way, and we have yb is equal to and minus L sine theta j, and yc is minus 2L sine theta j. And so by doing the virtual displacement, we have this one. We have these two. And it's okay. And now the last thing to determine is this spring tension. Of course, spring tension F equals to Kx is here. So, and it is in plus J direction. So it is F is equal to Kx. Now, the last thing is what is X? X is equal to the current length minus the original length. So this one is the length now. This one is the original length. Right? This one is the length now, 2L sine theta. I think you can get it. And this one is the original length before it is before we put force T onto the spring. So we put it there. Okay. And we have 5 equations here, and then we get we can get this one. Equation 1 becomes this one. And first of all, tension F is equal to half of T. And then we have we simplify this equation such that we remove this and we remove this. We will get this one. Okay. This is from the virtual principle we'll get this thing. Now for this one we have two solutions. One solution is cosine theta is equal to 0. The other solution is this part equal to 0. It's okay. We have two solutions. For the first solution, cosine theta equals 0. That means the theta equals to 90 degrees. It means the structure looks like this. Okay, it's because this one is 90 degrees. Okay. And everything is 1D, and the spring tension is in the direction of T, so this is one solution. For the other solution, theta is not equal to 90 degrees. It means we put this one equal to 0 and we get this. And this is the answer. This is the answer we want.